Okay, in section 4, we're going to really start working on factoring polynomials. However, today we're going to start with the most basic of those. We're going to factor out GCF, and we're going to factor some special type of polynomials. So the most easiest, most basic way of factoring a polynomial is by factoring out its greatest common factor. So you're going to look at all the terms in the polynomial, and in this case you have two terms, and we're going to try to factor out whatever's common, okay? So we look at the numbers first, and we start with 6 and 4, and we see that 2 is the greatest common factor of 4 and 6. And we look at x to the third power and x to the first power, and we recognize that they share one x to the first power. And so 2x is the GCF, or the greatest common factor, of the two terms in this expression. And then how do we come up with the rest of it? Well, basically we take 6x cubed and we divide it by 2x. 6 divided by 2 is 3. X cubed divided by x is x squared. And we do the same thing with the 4x. 4 divided by 2 is 2, and x divided by x is 1, and so we're done. And so we figured out that when we factor out a 2x, we're left with 3x squared minus 2. So this here is the factored version of this expression. In other words, we're trying to figure out what two things were multiplied to equal this binomial that we started out this whole thing with. And so how do we check it? How do we know we did it right? Well, let's just multiply it. Let's actually distribute. 2x times 3x squared is 6x cubed, and 2x times negative 2 is minus 4x. And notice that we go back to what we started with. So factoring is really kind of like, at first we multiplied, and factoring is really division. We're undoing the multiplication, and division undoes multiplication. We're just not dividing and taking away the 2x, we're just pulling it out and putting it in front of the remaining expression. So let's just do a bunch of examples of this. So again, you go through and you look at these. It's just asking you to factor, and we're factoring using GCF. So again, we try to figure out what number and or variables do they share. And we notice that -4, 12, and negative 16 all have a 4 in common. Now, when this first term is negative, it's kind of preferred that you pull out the negative value. We like that leading coefficient, or that leading term, to be a positive. So I'm going to factor out a -4. And they don't all share an x, so I can't take out a variable. And basically, if I take out a 4, or a -4, -4x squared divided by -4 is just going to equal x squared. 12x divided by -4 is going to be minus 3x. And negative 16 divided by -4 is going to equal positive 4. And so this is the factored solution. These are the two things that multiplied together to equal this trinomial. And again, you can always FOIL, or not FOIL, but distribute or multiply or whatever to just double check your answer. If I distribute that -4, notice that I should end up with the same trinomial that I started with, and I do. Okay, so you can always check your answers in this by just multiplying out, making sure it works. Okay, so when I ask you to factor, though, this is the solution I want. Now, you could have factored out of here a 2 or a -2 or whatever. However, you always want to factor out the greatest common factor, because you want to make sure that what's left doesn't have any other common factors within it, and it doesn't. And so I know I factored out the correct thing. When I get to number 2, again, I look at it and I notice that all of them have a 3 in them, and they also all have an x to the first power. So 3x cubed divided by 3x is going to leave me with x squared. 6x squared divided by 3x is going to leave me with a minus 2x, and 9x divided by 3x is going to leave me with a positive 3. And so this is the factored solution. So all I'm really doing on these problems is pulling out a GCF. Okay? Now, sometimes you get some where you have, notice you have two terms, x minus 2 and 2x plus, and then I have x minus 2 times a 3. So again, when I look at that, I have to pull out common factors. Well, guess what? One factor of each is an x minus 2. So that's my common factor. And when I take it out, it leaves me with a 2x plus a 3. And again, if I distribute the x minus 2, if I do this, I'm going to end up with what I started with. And so these are a little bit weird with the expressions, but they kind of work the same way. It just looks different. Again, here, this is like an x plus 3 times an x plus 3 minus a 4 times an x plus 3. So in both of these cases, both of these groups have an x plus 3 in common. So I'm going to factor it out, and it's going to leave me with an x plus 3 and a minus 4. So if I clean this up a little bit, I'm going to get x minus 3 times x, or x plus 3 times x plus 3 minus 4. And I can actually simplify the x plus 3 minus 4 to an x minus 1. And so this is my final simplified solution there. Now, I'm going to get to, now that we're done factoring out the GCF, and factoring the GCF is always your first step. It doesn't matter if it's a difference of squares or if it's special polynomial. Anything we do moving forward when it comes to factoring, you always want to factor out the GCF first. If it's there, if it exists, you want to do it. Now, remember that it says here, when two terms of a binomial are perfect squares with a minus between them, that is when you have a difference of squares. The square root, you square root the first and the last terms. One parentheses gets a plus, one gets a minus, and notice you have this, and they ask you to factor. This is a difference of squares. Now, how did all this come from? Because this seems very, very technical. Well, remember that when you had before, when we did multiplication, we showed you a pattern that if you have the first term and the second term that are the same, and the only differences are a plus and a minus, yes, you could FOIL a squared minus ab plus ab minus b squared, and your middle terms would cancel, and you'd be left with an a squared minus b squared. But so we told you, yeah, you can factor it or FOIL it, and you can get the final answer. You can cancel the middles and do the work, or you can memorize that this particular pattern always ends up in a solution when you multiply it that looks like a squared minus b squared. Well, when you're working backwards, when you go with the product and you're trying to get to its factors, this is really important that you remember that. So if your two factors each have a perfect square, they have a square root, and they're separated by a minus sign, that's a difference of squares, and that's when you apply this thing. So again, notice here to this one, notice that this is x to the second power. This one here is 2 squared, and notice that there's a minus. And because you have the first term has a square root, the last term has a square root, and it's separated by a minus, this is an x plus 2 times an x minus 2 situation. Those are my factors. Remember, this is like your a, this is like your b, so it's a plus b times a minus b. And these are the factors that created this binomial when multiplied. And so we'll do a lot of examples of these, and it'll become very common. But again, it's really great if you recognize that pattern because it'll help you to factor it correctly. So notice all these problems. So first thing is there a GCF here in number 5? There is not. There is no number that goes into 9 and 49. So now let's see, is the first term something squared? And yes, notice that it's 3x squared. Is the last term something squared? Yes, it's 7 squared. And is this a minus? And it is. And so this is, again, a difference of squares. This is a 3x minus 7 times a 3x plus 7. And so these are the factors that created that. So we're going to keep going. We'll do the same thing. Can we pull out a GCF? No, we cannot. So then let's just see, does this have a square root? Yes, this is 6x squared. Does this have a square root? Yes, this is 7y squared, and this is a minus. And so this, again, is a difference of squares. This is 6x plus 7y, and this is 6x minus 7y. Notice in this one I did the minus first and the plus second. Here I did the plus first and the minus second. Guess what? It doesn't matter. That's just whatever. For one reason, in one I did it first, and in one I did it second. It doesn't really matter as long as I always have one that's a plus and one that's a minus. So I go to number 7, and in number 7, the first thing I want to do is pull out a GCF. Notice that 4x squared minus 100, I have a 4 that they share. And so if I factor a 4 out, I'm going to get x squared minus 25. And now again, I ask myself, okay, is this binomial that's left over, is this a difference of squares? Is there a square root here? Yeah, x squared is x to the second power. 25 is 5 to the second power, or 5 squared, and this is a minus. And so the 4 that I took out is going to stay there, and then the x squared minus 25 is going to switch to x plus 5 times x minus 5. And that's how I get that. Now, you might say, did I really need to pull out a GCF? Well, let's say I had kept it like this. I know that this has a square root. It's 2x squared. This has a square root. It's going to be 10 squared. And this is a minus. So you're like, hey, I could have done 2x plus 10 times 2x minus 10. The problem is that because you didn't factor the GCF out at the beginning, the answer that you were left with has a GCF in it. In other words, there's a GCF to 2x plus 10. It's 2, which would leave me with an x plus 5. There's a GCF in this one. And if I take the 2 out, it leaves me with an x minus 5. And I can take these two GCFs and multiply them together, because right now it's 2 times x plus 5 times 2 times x minus 5. So I can do 2 times 2 is 4 times x plus 5 times x minus 5. And notice the answer is the same, but it was a lot more work to factor it out from here, in my opinion, than it was from the original. So again, I suggest you always take the GCF out from the very, very beginning. Okay? And so again, here I've got 25x squared and 36. None of these have a GCF. So I start looking at it and I'm like, well, this has a square root. It's 5x. This one has a square root. It's 6x. But this is a sum. And guess what? When it's a sum, it is not a difference of squares. So this cannot be simplified further. So this cannot be simplified further. Or factored. Cannot be factored further. How about that? It's done. This is the answer. Can't be simplified or factored. And so that's it for that. So let's do some more examples. And as we do these, we're going to get to some where really it's factor or factor fully, where we're going to get to it and we're going to be like, okay, I can keep going here. Like, first of all, in number 9, I cannot pull out a GCF. So I say, well, is there a square root here? And there is. X to the 4th squared is x to the 8th. 1 squared is 1, and this is a minus sign. So I'm going to start out by doing x to the 4th plus 1 times x to the 4th minus 1. Now, x to the 4th plus 1 is done, because once you see two terms, a binomial, there's no GCF, and it's a plus, there's nothing you can do anymore. But the second one, notice that this has a square root. This is x squared squared. This one has a square root. It's 1 squared, and it's a minus again. And so what happens is that this simplifies to x squared plus 1 times x squared minus 1. And so again here, I've got that, right? But now look, I have this last one. And again, x squared, this is x squared. The 1 is 1 squared, and it's a minus. So this one also can be simplified. This ends up being x plus 1 times x minus 1. And so my answer to this question is all of these. So x to the 8th minus 1, when I factor it out, I have to use this difference of squares 3 different times. My final answer is going to be x to the 4th plus 1 times x squared plus 1 times x plus 1 times x minus 1. And these are all the factors of x to the 8th minus 1. Okay? So you have to often keep going. You just can't stop when you break it down. Again, here I look for GCF. There is no GCF here. So this first one, I notice this is 25x squared squared. And this one here is 1 squared, and this is a minus. And so I know that I'm going to start by 25x squared plus 1 times 25x squared minus 1. Now again, the plus 1 is done. However, 25x squared minus 1, I can keep going. This becomes 5x minus 1 and 5x plus 1. Because again, 25x squared has a square root, which is 5x. 1 has a square root, which is 1. And it's a minus. And so, again, I have to include those. So this is 25x squared plus 1 times 5x minus 1 times 5x plus 1. And it doesn't matter the order as long as the three binomials are exactly the same. I keep going, and in this case, I notice that both of these have a 3 in common. So I can factor a 3 out, and I'm going to be left with 1 minus 4x squared. And then again, I ask myself, I know 1 has a square root, 4x squared has a square root of 2x, and it's a minus. So it's going to be 1 minus 2x, and it's going to be 1 plus 2x. And so those cannot be simplified any further. And so that's all factored. And notice that the GCF I took out is one of the factors at the end. It doesn't go away. It doesn't disappear. It's still there. I have to multiply all these back together to get back to what I started with. And then the last one, I've got x plus 2 squared minus y squared. So again, even though it looks different, this does have a square root, right? This is x plus 2 squared. This one here is y squared, and it's a minus. And so I know that this answer is going to be x plus 2 plus y times x plus 2 minus y. And I can clean this up a little bit. I don't need to put all those parentheses in there. I can just do x plus 2 plus y and x plus 2 minus y, like that. Okay, so I don't have to have the parentheses within the parentheses. But it's kind of, I know that's a little bit different. Again, here we come, and each one just gets a little bit more involved, a little bit more difficult. But again, same idea. Notice this is x minus 1 squared, so this is what's being squared. This one here is 3y squared, right? And it's a minus. So the first step is going to be to do x minus 1 plus 3y squared and x minus 1 minus 3y squared, like that. And so again, I can just write it as x minus 1 plus 3y squared and x minus 1 minus 3y squared. Or actually, I don't even have to group the x minus 1 there. Like that. So I know it's weird with the minus and the plus or whatever, but I don't know. I feel more comfortable. I personally feel more comfortable leaving it as a little group. And since I can't combine anything anyway, why not? But I know that one, those with the expressions within are just a little bit odd. Again, I come here 81 and 36, and I try to pull out a GCF or something. And I see that I can pull out a GCF here. I see that 9 goes into both of these. So I've got 9 minus 4x squared. And then again, now this is also a difference of squares because 9 is 3 squared, 4x squared is 2x squared, and it's a minus, right? So I know that this 9 is going to carry over here, and then I'm going to have 3 minus 2x and 3 plus 2x. And when I FOIL that out, FOIL these, and then multiply by 9, I'm going to see that that is the correct answer. And then the last one is x to the 4th minus 16y squared. And again, I go here. I see that this is an x squared to the 2nd power. This is a 4y to the 2nd power. And it's a minus sign. So I'm going to start by doing x squared plus 4y and x squared minus 4y. And again, I ask myself on this one, I know this one's done, and I ask myself if this would have a square root, but it does not. And so that's fully factored, and that's going to be my final answer. So now we move away from difference of squares, and we talk about the next two that were on our page for special products back when we did that. and it was, we talked about when you have an a plus b squared, meaning a plus b times a plus b, your product is going to be a squared plus 2ab plus b squared. And we talked about what happens when you have an a minus b squared. And we said, oh, your product is a squared minus 2ab plus b squared. And so if you learn that pattern, you could quickly multiply these two binomials without having to actually FOIL them out. And again, FOILing's not a big deal, so you didn't really need to know the pattern. Well, here, if you happen to have a trinomial that's a perfect square trinomial, in other words, it's a trinomial that fits this pattern, then you can figure out what the original factors were without having to do a longer method that we're going to teach you, and you should have learned before, but we're going to review with you on just factoring a trinomial. So how can I apply this? Well, I can look and see, is the first term of my binomial something that has a square root? And yes, it's x squared. Is my last term something that has a square root? And we're like, yeah, it's 5 squared, right? And then you're going to look at the middle term. Is the middle term 2 times the first term times the last term? 2 times the a times the b. So again, if a is x and b is 5, 2 times 5 is 10. 10 times x is 10x. And notice that this is 2ab. So if it follows that pattern, an a squared, a 2ab, and a b squared, then it's one of these. And then you look at the signs to see which one. Well, it's this one. And so what this means is that my pattern is going to be then x minus 5 squared. Those are my factors. This is an x minus 5 times an x minus 5. So again, it's just a pattern that you want to kind of visualize. It's going to be helpful in solving some problems. You always want to pull a GCF out before you even attempt it. And it will make your life a little bit easier down the road, you know, if you kind of get used to factoring like this. But again, if you don't, there's other ways to factor these. This isn't critical to memorize, but it's helpful. So again, we come here and we go to 16 and we're like, all right, is there a GCF here? Do 16, 24, and 9 have a number in common? And they don't. And there's not a variable either. So let's see if it follows one of these perfect square trinomial patterns. So does the first term have a square root? Yes, it's 4x. Does the last term have a square root? Yes, it's 3. And is the middle 2 times 4x times 3? Well, that's 8x times 3 is 24x, and it is. So notice this is a plus here. So this is an a plus b squared scenario. A is 4x, b is 3. And so this is a 4x plus 3 squared situation. So those are the two factors. This would be a 4x plus 3 times a 4x plus 3 if you expanded it out. And so we're able to factor this pretty quickly if we can kind of recognize that pattern. Again, we go to the next one. Ask yourself always, is there a GCF? There's not. And so we go and say, okay, is this first term, does it have a square root? And it does. It's 3x squared, right? Is the last term, does it have a square root? Yeah, it's 5 squared. And is this inside 2 times the 3x times the 5? Well, 2 times 5 is 10. 10 times 3 is 30x. And so, yes, this follows the pattern. It's a minus and a plus. So this is an a minus b squared scenario, which means a is 3x minus b, which is 5, squared are the factors. And again, you can FOIL this out and prove that it works, okay? And we go to the last one, and we look at it, and again, there's no GCF to take out. Is there a square root for the first term? Yep, it's 2x squared. Is there a square root for the last one? Yes, it's 1 squared, right? It's 1. And is this 2 times a times b? So is this 4x? Yes, it is 4x. It's a plus plus. So this is an a plus b squared situation. So a is 2x, b is 1. It's a plus, so it's 2x plus 1 squared. And that's how you apply the shortcut and the special factoring to this problem. And we'll have a few more. So again, I come over here, and I'm always looking for GCFs, but there are no GCFs here. None of these numbers have a GCF that a factor that goes into all of them. And so I have to go and say, okay, does the first term have a square root? Yep, this is a 6y squared. Does the last term have a square root? Yes, it's 7 squared. And is the middle term 2 times 6y times 7? And so 6 times 7 is 42. 42 times 2 is 84. And it's 84y. And so this works. So this is going to be an a plus b squared scenario. So a is 6y, b is 7, and it's a plus. And so these are the factors of that trinomial. And last but not least, we come to this last one. We try to pull out a GCF. There is not a GCF in the numbers. There's no GCF in the variables. And so again, I ask myself, is the first number, does it have a square root? And yes, it's 3u squared. Does the last number have a square root? Yes, it's 4v squared. And is the middle 2 times the first term times the last term? And when I multiply these, I get 2 times 3 is 6, 6 times 4 is 24, and I get 24uv. Now, I do think this is a mistake. I think for this problem, there was supposed to be a v there, okay? So let's assume the v was there. Then this would be an a plus b squared scenario, and this would be a 3u plus 4v squared situation. Okay, so that would have been the answer. If v, right? If no v, if it's supposed to have no v there, then this would be unfactorable for us at this point. We would have had to stop right there. We could not factor this one, okay? But again, I believe that this is just a typo, and I think there was supposed to be a v there, so this is the answer that we would go with.